Good morning and afternoon. My name is Guillaume Edlin. I'm the Global Maritime Autonomy Business Developer at Xblue, and with me today is Stéphane Van Uffelen.
Hi, Guillaume.
Good morning. Stéphane is the Technical Director for Maritime Autonomy at Xblue, and later on we'll be joined by Nick Lawrence, who is the Director of International Business Development at EdgeTech. Today's topic is to present you FlipiX, our new remotely operated towed vehicle. So basically, we are going to make a 25-30 minutes presentation, followed by a question and answer session. So please, write down your questions on the chat, which is available. We will answer them in the wake of our presentation. In a nutshell, Xblue has been working extensively on maritime autonomy for the past few years. We have an extensive experience in that field, and thanks to a unique combination of in-house expertise in navigation, artificial intelligence, robotics, shipbuilding, sonar systems, subsea positioning, and motion control. This unique combination of in-house expertise allows us to support the transition of the industry toward remote operation. Now, having said that, Stéphane, can you introduce us to FlipiX?
Of course, Guillaume. So, FlipiX is very much about a new generation of ROTV. It's designed, to convey and operate side scan sonar and magnetometer. And at the end of the day, the aim is really enhancing the service scope and the autonomous service scope. So FlipiX is designed, to be operated as an integrated autonomous solution or from a traditional survey vessel.
Okay, so what exactly are we trying to achieve from a mission point of view?
So we've got a lot of customer feedback. We've got the DRIX, and out of discussion with customer, we realized that there was a real need of uncrewed solution to combine UXO survey with hydrographic and geophysics survey. At the end of the day, from a customer perspective, it's very much about operation efficiency and reducing the cost. So if you are able, to combine the UXO hydrographic and geophysics survey with a combination of FlipiX and DRIX, you can, do all this together in a single run, resulting in this huge operation efficiency gain.
Well, if you tell me about hydrography, about geophysics and UXO, it sounds like pretty much like maritime renewable to me. Do you plan to use FlipiX for in support, for example, of installation and inspection for wind farms?
No, of course, out of all the discussion we had with our client, the EMR market is a key drive toward this integrated solution. But, looking more at the detail of how it looks like, so we keep the DRIX, as the main platform, to convey the multi-beam sonar and the sub-bottom profiler. And in the back of it, you've got FlipiX, which is being towed by the DRIX, which convey the side scan sonar and the magnetometer. Just to give order of magnitude, we've got a cable length in the range of 250 meters behind the DRIX. And typically, FlipiX is going to be operating down to water depth of 50 meters. Mm-hmm. So we truly think it's a kind of unique combination, that brings a true differentiation to the market.
All right, so DRIX plus FlipiX, I get it. That's a game changer for autonomous survey, and it brings a most comprehensive survey solution to the market. Great. But could you please provide us with more detail regarding the sonar measurement quality, for instance? Okay.
So, if you look from a client perspective, in terms of client need, it's very much about measurement quality and delivering, measurement to the client in the most efficient way. And it's also having a system, with an extended operating envelope to cope with all their need. So when you think about, side scan sonar measurement, having a stable motion, for the sonar as it's being towed, is extremely important. And when we started designing FlipiX, it was with, that notion of active motion control. If you look, at the waterfall display of a side scan sonar, if the sonar is moving, you will see some side artifact, on the edge of the image that usually, will kind of force you to plan for your survey line in a conservative way. To try to reduce the risk of, a gap in between measurement in two lines. So with FlipiX and its active motion control, you really reduce, the risk to rerun to fit a mosaic gap.
Okay, so I understand the importance of motion control. Can you tell us a bit more about it?
So previously, you saw a small video, of FlipiX in action underwater. So, it looks very much like a small underwater airplane, and in terms of altitude or depth control, we use the main wing, which is actuated by a linear servo motor. And FlipiX is, of course, fitted with altitude and depth sensor. But we also, implemented some side aileron, on the wing to control the roll, as well as an additional aileron in the back tail to control the pitch. So this is what allows us to, to have this very precise control of the FlipiX body motion.
But you're telling me about a very precise control of a FlipiX body motion. What sort of navigation accuracy do we have with the FlipiX?
Yes, so I would say, in terms of typical kind of control that we achieve on the survey line, so you can see, a graph of pitch and roll of FlipiX along the survey line, and you can see we're well within plus or minus 1 degree. So, also beyond, enhancing the measurement quality, having a stable platform and the active motion control also enables to do faster U-turn, which is also very important from an operational standpoint and, gaining time on your operation cycle.
Of course, when you go from one 9 mile to the other.
And also, in terms of performances, we typically run FlipiX, at altitude in the range of 5 meters.
Okay.
But depending on the terrain, you can probably go down. We routinely go down to 2 meters as well. So it's what we routinely achieve when we operate it, with some variation on the altitude in the range of a few tens centimeters. So.
Well, so you overfly the seabed at 2 meters of altitude. That's impressive. Can you? So it's. I understand you can use it with the DRIX USV or with a USV, as a matter of fact. How about using it with survey vessels?
No, so of course you can use FlipiX with a traditional survey vessel. At the end of the day, it's an active, tow body. So FlipiX was designed with a pressure rating of 300 meters of water depth. And of course, you can use it with a traditional survey winch, with a coaxial cable that you will usually, find on these winch.
All right. Look, if I were a service providing company, what edge would buying and using a FlipiX give me?
So we already mentioned it, combination of DRIX and FlipiX, it's very much about cost saving, and increasing operation efficiency. And we, as IXBlue, we try to reuse all the return of experience, that we had on the DRIX, when we started designing FlipiX, And we think it's really the very first ROTV that was truly designed for autonomous operation when combined with a USV. And currently, we strongly think it's a unique solution on the market. And we're back, to the IXBlue technical depth, and all this unique in-house expertise we've got access to, that has really enabled us, to design this fairly unique ROTV. And it's the IXBlue long-term vision, to kind of develop a comprehensive ecosystem of maritime autonomous solution to support our client needs.
Okay. And sensor-wise, what sort of equipment can you fit on board FlipiX? Okay,
so FlipiX was primarily designed for to support UXO operation, which means to convey side scan sonar and a magnetometer. So the side scan sonar is rigidly attached to FlipiX, so that we've got full motion control of the sonar itself, and the magnetometer are towed behind FlipiX. So you can see on this video, FlipiX in action. So you can see the main wing, the body. At the bottom of FlipiX, you can see HTech 4205, being conveyed. And then on the back, you've got the magnetometer, which is being towed. Also to mention, that iXblue is planning to release a magnetometer array deployment kit in the second half of 2022. UXO survey is also about, surveying the magnetic gradient, and we are planning to have 4 magnetometer arrays that can be towed behind FlipiX. As most of the iXblue product, we are designing, our equipment as open platform, and as versatile for future expansion. So it's the same with FlipiX. We've got an IP Ethernet backbone that should enable, future interface, and as part, of what we traditionally, and the way we traditionally engage our customer, we're very open, to customize and develop some solutions that are, fit for purpose for our customer.
All right. Well, thank you very much. That was very clear. So, Stefan, gathering data is one thing. How do you geo-reference them? And by that, I mean, in essence, how do you position the FlipiX?
So, we're talking about, the technical depth of iXblue, and the range of expertise we've got in-house. And in terms of acoustic positioning, we've got the GAPS USBL system. And, the GAPS is one of the leading solutions in terms of, subsea acoustic positioning. It has really outstanding performances in terms of shallow water, which is a kind of market, that we are targeting with FlipiX in its fully autonomous solution. And so as a part of the FlipiX kit, we've got MT9 acoustic beacon, which is installed, and that allows a very easy interface with the GAPS and a kind of turnkey solution for our customer.
Right, the GAPS USBL. Could you please give us some practical example of operations?
Yeah. So, within iXblue, we are very lucky, that we've got the Maritime Autonomy Campus in the south of France, in La Ciotat. For us, it's a great asset. It gives us the ability, we've got direct access to water. So we've got, whether it's a Trix or FlipiX, we've got vehicles operating on a daily basis, and it's very important for us, to build all these operating experience. And, just to give you a practical example, so that one, it's a survey that we did around a site which has anchoring chain at the bottom of the graph here. And this graph gives you an idea of the kind of survey line that we did in this operation. So the survey area is divided in 2 zones. And as you can see, to exit, one line, U-turn and go to the other one, we need something like a distance of 300 meters. And this distance, is much reduced compared to what you would have with, a more traditional, survey vessel. And also to mention that during the U-turn, FlipiX, will remain, at its operating depth or altitude, during the turn. So you do not only save, in terms of reducing the distance to the U-turn, but also you don't need, to bring the ROTV back to surface during the turn. So all this, is bringing, is a way to reduce the operating time.
Okay, this has been taken using the HTech sonar, right?
Yeah, of course, yeah. And if we look at the way it looks like, from the command center, so the operation I displayed before was done, remotely in over the horizon mode from our control center. And on the top side, you can see the multi-beam data that are being acquired with a FlipiX position in the back. And at the bottom, you can see the waterfall display of the sonar, side scan sonar image as it's being built. If we have a more, closer look at these data, you can also see that the edge of the sonar image is very smooth, which clearly highlight, the stability of the FlipiX platform. And, just to conclude on that side, I really like showing this picture in the sense that it's highlighting, it's a sonar image that was done during a U-turn of FlipiX, and you can still see, the very smooth edge of the image. We keep a very good image quality. Not to say that the surveyor, will start using the measurement during the U-turn, but once again, it's a way to highlight the stability of the FlipiX platform.
You give me the perfect occasion to transition to Nick Lawrence. So Nick Lawrence, the EdgeTech Director for International Business Development, is joining us today for this X Live. Thank you very much for being here, Nick.
Thank you for having me.
Wow. Could you comment on the importance of good motion control regarding side scan sonar measurement quality?
Well, as you've seen from the data you've got, nothing beats having a stable platform when it comes to the quality of the image you get from your side scan sonar. With a wide vertical beam width, side scan is fairly immune to roll artifacts, but with the narrow long track beam width, pitch and yaw movements can cause issues with the side scan sonar data. At its worst, this can be seen as striping in the data. Some of our systems have a motion tolerant mode that addresses this issue, but then there are some trade-offs in terms of resolution. And so with a more stable platform, you can take advantage of the highest resolution that the system can offer. The actual toefish pitch and yaw comes from the vessel movement at the surface being transferred down the tow cable. So the combination of the DRIX and FlipiX has two main advantages. Firstly, the DRIX itself is more stable than a typical manned vessel, especially when you're talking about small boats used in shallow water operations. So there's less motion at the top being transferred down the cable. And secondly, the motion control of the FlipiX means that it removes what motion would otherwise have been apparent at the bottom end of the cable. So essentially, you have a very, very stable side scan, so very good data.
All right, thank you very much, Nick. How difficult was it to integrate the 4205 onboard the FlipiX?
It wasn't very difficult at all. It was very easy. We already offer what we call an ROV/ROTV option on the 4205. Essentially, this gives you a 48 volts DC power input and a direct Ethernet communications link, which is in addition to the normal tow cable connection. This means that the user can just connect the 4205 directly to the power and communication systems of the FlipiX. This is one of the features of the 4205 series. We have a wide range of frequency choices and a lot of options that are available on the systems. The 4205 is a natural progression from the very successful EdgeTech 4200 series and offers improved range performance, extra variance and improved resolutions. So we now offer a tri-frequency toefish like the one currently installed on the FlipiX, and that gives the user the ability to select on the fly any two of the frequencies available for simultaneous dual frequency operation. The idea of this is that the same toefish can be used for a wider variety of tasks. We also offer dual frequency multi-pulse toefish with a variety of frequency set options, and the multi-pulse can double the along track ping rate, which can be advantageous when you are running at higher speeds. So again, the ability of the FlipiX as a stable platform close to the seabed gives the operator the ability to use the highest frequency combination towfish that deliver the best resolutions, and to do so to the maximum effect.
Well, Nick, thank you very much. We were very impressed by the capabilities of the 4205 ourselves. Nick, you stay with us till the question and answer session. So if any one of you has any question to put to Nick, please feel free to write them down as well. Thank you very much again, Nick. Stefan, one quick question, if you don't mind, back to you. Could you provide more details regarding magnetometers measurement quality?
Yeah, of course. So far we had a lot of focus, on side scan sonar, but the magnetometer is also a key part of UX operation. And when you are talking, about the quality of, magnetic field measurement, it's very much about the noise that you got on the measurement. And this one is an example, of a magnetic field measurement along one of the survey lines that I displayed before. So you can see, some targets that are being detected through peaks that you see on the graph. But more interestingly, it also gives you an idea of the kind of noise that you will get. And here we're well within the plus or minus 1 nanometer in terms nanotesla, in terms of the noise on the magnetic field. A big part of it is, the composite construction of FlipiX. FlipiX has a very low magnetic signature. And in practice, we just have to tow FlipiX, within 1.5 meters. We just have to tow the magnetometer within the length of 1.5 meters behind FlipiX, So.
All right, thank you, Stefan. So up until now, we mentioned what FlipiX was, the advantages it brought to the market, to the sensors which were mounted on board. I do have a last question for you, if you don't mind. How about launch and recovery?
Yeah. So Guillaume, you're perfectly right. Whenever you're dealing with maritime autonomous system, the launch and recovery is a question that we get from customer, because it's one of the key, operational steps, is getting things in and out of water. So when we started, designing FlipiX, we had this very much in mind, and we designed, a very simple and ruggedized launch and recovery system that can be fitted on, support vessel as small as a rib, as you can see on this picture. So in terms of running FlipiX, what do you need to do? So you need the launch and recovery system. We also provide a very simple spooler, to wind and unwind the 250 meters of cable, towing cable in between Drix and FlipiX. And within the Drix, you need to install a small multiplexer for the communication over the cable, as well as a 10-meter floating extension cable, and we will see the way it's used afterward. So having a look, this video, will kind of show a different step for the launch and recovery of FlipiX. So now you move on site, with FlipiX on the back of your support vessel. The support vessel gets close to the Drix, and then you catch the floating extension cable with a pole. Then the next step is to connect this extension cable to the main FlipiX cable, the 250 meter of cable, and then the Drix move away, manually piloted, and you unwind the 250 meter of cable, and then you connect FlipiX. And once FlipiX is connected, you just release it from the launch and recovery system, and you are ready to go. Whoa. So as you can see, it's fairly straightforward and quite simple in terms of the operating step. Now you can see, FlipiX being ready with a magnetometer in the back and ready for an operation.
That's impressive.
And then, so you start, your survey, and then regarding, the recovery part, you kind of do the same step in the reverse order. First, recatch, the extension cable to disconnect the main FlipiX cable from this extension. Once it's done, the DRIX moves away, and using the spooler, you start winding the cable back onto the support vessel. And once you've got, and then I mean, you kind of recover FlipiX on its launch and recovery system. As you can see from a crew standpoint, you need, something like 3 people, one guy to take care of a boat and 2 other one, to deal with the recovery of FlipiX. So once again, fairly straightforward, and we are really providing the entire solution, not only, the fancy part with the autonomous vehicle, but also the launch and recovery part.
Well, definitely straightforward. Thank you very much, Stefan. So the presentation is now over. We are going to start answering the questions you might have. Okay, let me have a look at the questions. Okay, so Thorsten is asking, can you still carry out moving sound velocity profiles from the DRIX for use with the MBES at the same time as you are towing the FlipiX?
So as a matter of fact, FlipiX is also equipped, with SVS probe. So the most straightforward way to do your velocity profile would be to use the FlipiX sound velocity sensor, I would say.
So Martin is asking whether we can use it with synthetic aperture mapping sonar.
So I would say, at this stage, we're talking, about reducing the operating footprint, and we're really targeting, UXO operation. So we try, to keep FlipiX, in a size, that can be hand carry and managed, by operator by hand, without the need of heavy, lifting equipment. But the technology that we develop for FlipiX, most likely in the future will be used, for more advanced, motion control of the SAMs as we move along. But it's not done yet.
Alistair is asking, what is the hindrance of DRIX when towing FlipiX?
So of course, we've got an impact of kind of towing FlipiX. It's adding some drag to the DRIX. So in terms of the actual autonomy, we're talking about something, I would say, 2 to 3 days of, kind of.
Okay, 2 to 3 days. And of course, the environment has an impact as well. Rocco is asking what FlipiX maximum payload is.
So, well, regarding payload, I would say, it's how do you define maximum? So, as I said, it's designed to be versatile in terms of interfacing with new type of sensor, and usually we built, a custom buoyancy, module to compensate for the additional equipment. So I think that one is really open for discussion in terms of client need. We got clients. We had some requirement, regarding interfacing with camera, for example, which we think is feasible. So please contact us, in terms of your specific need, and we'll provide you some more detail on this specific topic.
Absolutely. Abdelaziz here is asking whether FlipiX would be able to follow a pipeline or a cable subsea.
So at this stage, we don't have active pipe tracking on FlipiX. That's the way it is. On the other end, as we said, since we are running the multi-beam at the same time as FlipiX, well, you can get some insight of where the cable or the pipeline is located, and maybe adjust, some trajectory depending on this measurement. But we don't have an active pipe tracking at this stage.
Okay, so Thorsten is also asking, is the FlipiX deployed and recovered autonomously by the DRIX at sea? And if so, could you show us the last system that is used for this? I think we've obviously answered that question.
Yeah, so the launch and recovery is done, through light support vessel, as you saw, not from the DRIX itself. And I think the video was self-explaining.
So Alastair is also asking if using FlipiX with a DRIX, how much of the sensor data can you get to show in real time?
So all that, kind of depend on, the connection that you have in between, the kind of connection that you got in between the DRIX and shore. All the case studies that we presented, was done with 4G, and we managed, to get the side scan sonar waterfall display in real time. I would say, one area where we still need to work on, it's full OTH over satellite link. And from that standpoint, most likely what you will get access is more kind of snapshot, of the sonar image as you run the operation, but not the real-time data.
Okay, just to thank you very much, Stefan. Just to remind everyone, DRIX can be fitted with. It's all a matter of bandwidth, basically, but DRIX can be fitted, is fitted by default with Wi-Fi. We've got LT, the MBR from Kongsberg, and high bandwidth satellite communication, as well as safety satellite communication with an Iridium. So Duncan is asking, in over-the-horizon operations, how does XBlue manage the data that needs to be transferred and viewed in real time, and this will increase significantly with the addition of these sensors for QC?
Yeah, so as you could see in the, during the presentation, the OTH operation we're currently running are done, with a remote desktop connection. But as part of, the DRIX ecosystem, we've got the Cortex software, which is kind of taking care of the autonomy and the management of the vehicle. And as part of this Cortex software, we've got a module which is managing the communication over, a satellite or 4G link. And we've got a notion of data priority management and so on to make, efficient communication on low bandwidth, high latency satellite link. So FlipiX currently is not integrated in this solution, but it's something that will come in the near-term future, so that we've got full support of FlipiX over satellite link.
All right, thank you, Stefan. Neil is also asking to expand on the autonomous aspect. Is this capable of totally autonomous piloting within the limits of the cable length, or is this remotely controlled?
So that one, I mean, is the user is kind of setting a target in terms of depth, and then it's all fully automated. I mean, we've got a control algorithm running on FlipiX, and the control of altitude or depth and pitch and roll is done completely autonomously.
Yeah, it's and we do also, as a reminder for everyone, we do supervised autonomy of the whole spread, I would say, the DRIX plus the FlipiX.
Yeah, and you're completely right. We always have, it's part, DRIX concept, which is this notion of supervised autonomy, where you always have a DRIX supervisor, in a remote operating center to supervise the operation.
Okay. Philip is asking what is the max C-state acceptable for pitch and other attitude stabilization?
Well, I think, our experience, if you are kind of controlling the altitude, the C-state does not impact too much. So at the end of the day, the DRIX, is a very stable platform, in terms of forms, versus C-state, and of course it's kind of minimizing the cable motion, and kind of strongly reducing the impact of, the cable traction on the altitude control. So so far, we've been operating, FlipiX up to C-state, strong 2 to
to 3, yeah.
Yeah. And we have not seen a major impact on the stabilization performances.
Okay, thank you, Stéphane. Hiroshi is asking if it's possible to automatically maintain the altitude of FlipiX from the seafloor in areas where the seafloor altitude is not flat. Very good question.
Yes, of course. So DRIX is fitted with an altitude sensor, and it's this measurement that we use in the control loop, to control the altitude. So if you've got terrain change, the FlipiX will follow.
And don't forget, if I may, that we've got DRIX sensors clearing the way 200 meters before FlipiX.
Yeah.
So that gives us a provision of warning, which is enough to influence on the FlipiX altitude keeping if needs be. I mean, that's
yeah.
Okay. Abdelaziz is asking if it would be possible to mount camera, you've answered that one, on FlipiX, plus side scan sonar, plus mags or array of mags.
Yeah. So I think the array of mag, we mentioned that we are planning to reuse it in H2 this year. And regarding the camera, that one really depends on client-specific needs, and we're open for discussion on that topic.
Now, Philippe is asking, how will DRIX and FlipiX manage detection and reaction to a steep cliff that could be seen first on DRIX bathymetry? Will DRIX stop or avoid? Will the winch bring the FlipiX to surface? So I think we've already started.
Yeah, I think that one we answered. So in terms of, in case of steep terrain change, then the operator has, the 200 meters, well, since the DRIX is 200 meters ahead, can make decision, in terms of, adjusting the altitude to go safely in those areas. So that's
all right. Now, Mark is asking, what approach do you envisage for enabling seabed sampling for validation of the geophysical data? And will you also be able to perform SBP in addition to side scan sonar?
Yes, so it's one thing we mentioned. The DRIX gondola can accommodate, the gaps, the echoes, and a multi-beam all in the same package. So that one, it's really a key part of the concept of FlipiX and DRIX. Getting back to the DRIX gondola, once again, it's an open platform. So, of course, in terms of multi-beam sub-bottom profiler, we interface with the equipment as per our client need. So whether these are IXBlue equipment or third-party equipment.
In short, for specific applications, please do not hesitate to contact us. Oliver is asking if we are able to steer the FlipiX laterally. The Scanfish was equipped with a series of flaps allowing the operator to change altitude, but also to move laterally, especially useful when targeting difficult infill lines.
Yeah. So at this stage, we don't have the steering ability. So it's one thing we are keeping in mind. While designing FlipiX, we wanted to, in the first release, to keep the system fairly simple, without too much complexity, to keep it, as I said, fairly small in terms of its size and, the ability for an operator, to handle it easily. So we decided not to add the complexity of steering, but once again, it's something that we actively keep in our mind at this stage.
All right, thank you, Stéphane. Well, here we've got Stan asking what is the production lead time for FlipiX?
So production lead time, it's going to be in between 6 to 9 months, so that one is also, it's part of a discussion that we normally have with clients, depending on our manufacturing load and the other builds that we've got ongoing. So, but I would say, 6 to 9 months is a kind of...
Okay. Philippe is asking if DRIX will adapt its course on the survey planning depending on the FlipiX position in areas with a strong current to maintain the side scan sonar on track?
So I would say, that one, if you start having strong current, there will be a level of calibration, that will be required, to understand the offset that you will have in between FlipiX and so at this stage we don't have, an active. Well, the DRIX is kind of following its line, and FlipiX is following behind. I would say that we are planning to have a tighter integration of the autonomy and FlipiX and the DRIX in the near-term future to allow some more active line keeping on the FlipiX side.
Interesting. Okay. Jean is asking us to confirm the maximum operating water depths for FlipiX when towed by the DRIX.
Yeah. So that one, we are talking about 50 meters of water depth that we can do. That's the water depth that we
currently that's what we have, and we're looking to go a bit deeper, but it's not going to be more than 70 meters probably, as you were saying.
Currently, as I said, 50 meters is a figure to keep in mind.
Now, Wissam is asking, what is the maximum depth detected by FlipiX? Well, I would be tempted to say that depends on the sensors you've got mounted on that.
Yeah, but FlipiX itself is designed to be operated up to water depth of 300 meters, in terms of, and regarding the cable length, there's a level of adjustment that is possible. I mean, we talked about operating from a survey winch, so once again, that one has to be looked at on a case-by-case basis, depending on the concept of operation of our client.
Okay. Simon is asking, what is the maximum depth operation for FlipiX?
That's what I just answered, I think.
Or is there several lengths cable?
Yeah, so I think I already answered that question.
That's all right. So AI, are there long-term plans for deploying FlipiX using a USV-based LARS and winch solution?
I would say not at this stage. We think, in terms of autonomy, we need to move step by step, to have market acceptance, and launch and recovery from a USV still remain, a risky and complex operation. So currently, it's really launch and recovery from very light support vessels that we are kind of promoting.
Okay. Matt is asking if it's possible for the remote operator to create an infill line for the FlipiX during operations on the fly.
Yeah, well, it's once again, this is very much driven by the DRIX autonomy. So that one is completely possible. It's just, active mission replanning through the DRIX user interface. So that one shouldn't be a problem. Okay.
And Mike, do you have any data, raw or processed, from FlipiX that is available to review? It would be very useful to get a hands and look at data from the platform.
No, so I think that one, we can, we got a significant amount of data sets that we can make available to clients if they want to check for measurement quality or, so shouldn't be a problem. Just contact Guillaume or one of the business guys and we'll make it happen.
Okay, and looks like we've answered all the questions. So, Nick, thank you again very much for joining us today. Again, it's been a privilege to work with your fantastic piece of equipment, the 4005 from EdgeTech. Stéphane, thank you very much for answering and allow us to grill you on a number of sometimes difficult questions. And I personally thank you all for attending this webinar. Please contact us if there is any pending question. And I wish you a wonderful day. Thank you very much, everyone.
And see you in the field very soon with DRIX and FlipiX. Have a good day.